Auto address configuration. Auto address configuration. You see the word it clearly says automatic. So there is no need for DHCP. You will get an IP address. Let me quickly show you that. Auto configuration works. You see, you've got a router here, and this has got an IP address. Let's say 10.0.0.1. And if you need these computers to be the part of this network, what is needed? What IP address is what IP address should I have here? Can I have 192.168?
No, no, there should be the similar network, similar subnet.
Only the network portion should be same. So you will say 10.0.0.2, 10.0.0/8/. Same like this. If you will have an IPv6 address here, say 2002:1/64. Out of 128-bit, 64-bit is network. You remember yesterday I finished saying like this, if you have something like this, what does this mean? This means 2002:. Yeah, this is what it means. Right? So this means that you need to fill the other hexadecimal with 0. Anyway, I want to delete this now. So what we have given is an IP address 2002:1. And if you will have an IP address starting with 2002 here /64, you will be able to take part in this LAN. Am I right? The network portion, that 64-bit should be what? 2002:2. A, B, if you will have this 64-bit in common, they form one network. That is what going to happen. You see, this router joins a multicast group called FF02:2. With this multicast address, what this can do is, this router can say in a layer 2 level, because this address works in both layer 2 and layer 3. In a layer 2 level, this will say, I have a network 2002:/64. And this address scope is only one hop. It will go here and then disappear. It will go here and it will disappear. It won't go more than one hop. And this router comes to know about the network portion from the layer 3 multicast traffic that was coming. So these PCs take that information, learn that information, learn the network portion, adds the MAC address of this PC. See, network portion is 64. You need another 64 bit to identify the device. So it takes that 48 bit MAC address. What is the size of MAC address? 48 bit. How many more bits you need? You need another 16 bit. It adds another 16 bit value. This is how it gets a unique IP address. Because the MAC address is unique. When a MAC address is added to this network 2002, A is now having a unique IP address. B is having a unique IP address in the network 2002. Did you understand what I said?
Yeah, that's right. Yeah.
I want to show you this. Before that, how is the 16 bit added? What is the value that will be added? It will add this value F F F E. This is that 16 bit that gets added to the MAC address. This is the 16 bit that gets added to the MAC address. FFFE. Yeah. So it takes the MAC address, adds this FFFE. It will also invert the 7th bit from the left, which I'll explain you later. So now I'm going to simulate this. Now, router 1, I'm going here and saying hostname R1, interface Ethernet 00. Please listen carefully. IPv6 address 2002::1/64. I have given an IPv6 address. When you give an IPv6 address, a link local address called FE80 FE80 will get generated. Let me show you that. I did not say no shutdown. Interface Ethernet 00. Right, when I say show IPv6 interface brief, see that's the command IPv6 interface brief. You can see this is not configured by me. I did not give this. I gave this automatically a link local address. It's for the machines to interact. With this only they learn the MAC address of the neighbor. FE80 will get generated. You know how this is? This is taking MAC address. See, FE gets added right in the middle of the MAC address. That's what I wrote here. This is the 16 bit that is added right in the middle of the MAC address. And now this is the network this router belonged. Now I'll go to router 2. Host name router 2. Listen carefully. I'm not doing anything other than saying no shutdown. Nothing except no shutdown. Show IPv6 interface brief. No link local address, nothing. But listen carefully. As soon as I go and say here, IPv6 address auto configure. As soon as I say this, a link local address will be given. Let me show you that. Look at this. Because to do conversation, there need to be an address. A link local address is generated. With this only, the multicast, they do the conversation. See, if router 2 says I am talking, I am the source of this multicast, it needs an address, right? This is not a multicast address, this is the source address, and it will use ff02 colon colon and ff02 colon colon 1 both. Let me show you that. Show IPv6 interface Ethernet 0/0. You will see ff02 colon colon 1. You see, this is the unique multicast address that is only for R2. If you see in R1, you will see different multicast address. Show IPv6 interface Ethernet 0/0. You see, here you have 1000, whereas here you have 2000. That's a unique multicast address to identify this device. This information will also go to R1. So R1 will use this multicast address and speak to R2 so that no others can learn. See how secure it is. Now, did I get the IP address? No, you will not get the IP address because there is one more thing need to be done. Before that, I want to go to R5. Also, I'll go to R4. Also, I'll go to R3. Yeah. So now, show IPv6 interface brief. See, still you don't have an IPv6 address starting with 2002. Why? Because by default, no router here is enabled with IPv6 routing support. I repeat, no router in this environment right now in Cisco enabled with IPv6 routing capability. See, it accepts IPv6 address. It generates link local address. Even a host can generate. A computer can generate link local address. Only a router can provide this auto address service. So what is needed is you need to go to R1, and only on R1 you need to join a multicast group called FF02 colon colon 2. Right now you have only colon colon 1. When you type IPv6 unicast routing, you will find FF02 colon colon 2 multicast. As a result, the service that we were talking about is now received. You see, starting with 2000, and this is made out of MAC address. Right in the middle, FFFE. You can also see in R3 now. Earlier you were not having, but now you have. All beginning with 2000 only. All beginning with 2000. So now from here, if you try pinging 2002 colon colon 1, you will be pinging. See how quick it is pinging, not even a single packet lost. And if you copy this address and go to router 3 and ping, you will be pinging. See how IPv6 discovers the neighbor. Before you ping, the neighbor is already discovered. Whereas in IPv4, only when you ping the first time, the ARP will try to discover. And if you see show IPv6 neighbor discovery, ND, show IPv6, neighbor. You can see their MAC addresses. Learned. Show IPv6. There's a command called ND. Something new. This is the first time I'm using this command. Okay, anyway. You got the MAC addresses already for all the devices. You can ping anyone from here with the new MAC address that you learned. If you go here, show IPv6 interface brief, you can copy this address. You can ping from anywhere. Things. Did you understand auto address configuration?
Yeah, I mean, that's all good, but I have some questions in here. I mean, two, three questions. Can I ask one question?
Yes, yes, yes.
Okay. This link local address is the layer 3 address, right?
No, layer 2 and layer 3.
This 2002.
That is not linked local address. That is global unicast address.
No. I mean, that global unicast address works in only layer 3.
Yes.
And the link local address, it works both, like layer 3 and layer 2.
Layer
Right?
2, with the help of that, it discovers layer 3 and then it becomes layer 3.
Okay. Now, if even we don't provide that global unicast address, and if we enable the IPv6 routing in the R1, it can also be able to do the dynamic discovery. I mean, sorry, auto config, right?
No, R1 will not have anything to give. You enable routing capability, but what is to give? You have not said what to give. You should tell what network to give. 2002 network to give. I have configured give 2002, isn't it?
Okay. This global unicast address has the is worked in layer 3 in network
This
in network.
address is
Yes.
mandatory because when you say IPv6 unicast routing, this is the network portion is copied and sent as a layer 2 multicast to this guy, to this guy, to this guy, to this guy, saying, hey,
Right. Okay.
I belong to 2002. And
Hmm.
the other router says, okay, I am configured to do auto configuration. So let me copy your network portion and take
Hmm.
my MAC address, extend it by adding FFFE, and have my own address.
Right. This is, I understand. The link local address, it also have the capability to work in layer 3,
Yeah.
right?
But you cannot
So,
use it for routing. FF FE80 addresses are not for routing purpose. It is only for neighbor discovery purpose. It works in layer 2 and layer 3 for neighbor discovery purpose.
okay, understand. Yeah, that's fine. So good.
It's only for machines.
Yeah.
If you want to ping, of course you can ping, but you need to specify the routing information. Say, for example, I want to ping this address. If you simply ping, it won't ping, you see. If you simply ping, it won't ping. It is saying, what is the outbound interface? I say Ethernet 0/0. Now it says you have to type fully Ethernet, ETHERNET. Okay, 0/0. Now it will ping. So you need to provide the routing because routing support is not for FE80. That is how they have designed. They have designed IPv6. They have designed IPv6 not to provide routing support for FE80. So you need to route by saying this is the exit interface. But for 2000, you will have route in the routing table. You see, For 2000, you have route pointing towards an interface, but for FE80s, there is no route in the routing table. You got it?
Yes, I got it. I got it. Yeah, yeah, yeah.
What are the other questions?
No, these are the questions. Yeah.
All right. Arun,
Yeah, sir.
any question from your side?
No, sir. That's okay.
Okay. Try this in your side. I'll stop here.
Okay.
We'll see some other day. We'll continue this
Okay. No
another
worries.
day.
Yeah, sure.
Okay. Thank you so much.
Okay, sir.
Take care.
Okay.
Bye.
Okay, sir.